Everybody, tonight we're trying to show this astronomically large number, 2 to the 385th power minus 1 is equal to a multiple of 2047. We'll write it like this. Okay, and that's exactly what this means right here, folks. This modular arithmetic notation says the left-hand side is congruent to 0 if and only if 2047 divides the left-hand side minus 0. Okay, so we want to show this. We don't necessarily have to find the value of m. We just want to show divisibility by 2047. Okay, now the prime factorization gives us a little bit of insight here. Notice this 11 right here. Recall that 2 to the 11th, and this is a common power, so 2 to the 10th is 1,024, 2 to the 11th is 2,048. Right? Now we have 2048 minus 1 right above here, okay? And so that motivates the next piece of algebra here. We rewrite 2 raised to the 385th power as 2 to the product of 11 and 35. And laws of exponents gives you this statement right here. And again, 5 times 7 is 35, right? And then we're using the 11. Okay, so we get this statement here, and then we just use a fairly routine algebraic formula here. This, if you think of this as b raised to the n here, where n is 35. Okay, that we would, let's just write it right over here. We get b to the n is equal to b minus 1 times b to the n minus 1 exponent plus b to the n minus 2 all the way to 1. There's a lot of cancellation going on due to the presence of the minus sign, minus 2 right here. And I'll leave out the rest, but that's the pattern that prevails here. A very common factoring form, like that. And so you can see exactly what's going on here. B, this part right here would be like your B, right? 2 to the 11th is your B. And you get this form here. This would be 35 minus 1, 35 minus 2, all the way out to the end. 2 to the 11th raised to the first power right there, if you want to do that. Okay, so it is in the form. You just have to be cautious of what you're calling your b. Okay, but notice that 2 to the 11th is 2047. All right, and so we did write our original expression as a multiple. In other words, what we called it m right here. Okay, this whole parenthetical object right here would be m. Okay. Now notice also nothing special about 2047. If we had written this as, so I mean this completes the idea here, but we could have done it like this: 2 to the 5th. We could have rewritten everything like this: 2 to the 5th. And what would that be? You'd have 5, and then you have 77 left, right? Is your remaining exponent. 5 times 77 being 385. This is 2 to the 385. Right here equals, this equals that. And then when you do the 1 business, you get the same old thing. You would have 2 to the 5th minus 1. And then there's no need to write down the rest of the stuff. Okay. Okay, but this would be 31. And there's other combinations also. So in other words, this also could have just as well been 31 modulo 31. But anyway, there's, due to the way you can rearrange the exponents, there's other ways to do it as well. So anyway, that does it. And this is an awfully big number. I don't know if I can pronounce it. 161 octrigintillion. Octrigintillion, I think. No, octrigintillion. octrigintillion, awful big number. And there's a lot more to it than that. Anyway, thank you for viewing.